Hello everyone. Today we are going to look at a very perfect calculator free method with which we can solve this problem here. We are asked to calculate the area of this triangle in yellow color. Let's label this point here P, this point Q, and this R. So we can call it triangle PQR. From here, they said the quadrilateral ABCD is a square-shaped quadrilateral. That is, this quadrilateral here is square-shaped. And we can see the length of this side is 10 kilometers. So how can we solve this? Well, it is very simple. Starting with this square ABCD, we know all the four sides of a square-shaped quadrilateral are equal in length. That is, this side AB, this side BC, this side CD, and this side AD are congruent. So since this side BC has its length to be 10 kilometers, this side, this and this must also be 10 kilometers in length. Now another property of a square-shaped quadrilateral is that all four of its angles are right angles. That is, this angle, this, and this are right angles. Now we know if a circle is fitted perfectly in a square, the circle touches every side at its midpoint. That is, this point P at which the circle touches side AB is the midpoint of line AB, meaning this segment AP and this segment BP are congruent. So since the whole length of the line is 10 kilometers, this part and this part each will be half 10 kilometers, which is 5 kilometers. Come here also, this point R at which the circle touches line AD is also the midpoint of line AD. Therefore, since its whole length is 10 kilometers, this part and this part must be 5 kilometers each. Now look at this triangle APR also. It is a right angle triangle, and we have this side AP and this side AR to be equal in length. That tells that the triangle is an isosceles right angle triangle. The angles of an isosceles triangle we know are 90 degrees, 45 degrees, and 45 degrees. So since this is 90 degrees, this angle and this angle must be 45 degrees each. Now if you use the Pythagorean theorem on triangle APR, we know the Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. Let's label it y. So by the Pythagoras theorem, y squared equal to 5 squared plus 5 squared. 5 squared plus 5 squared is same as 2 times 5 squared. So y squared equal to 2 times 5 squared. Take the square root of both sides. Here square root of y squared is y, while here square root of 2 times 5 squared is root 2 times 5. Root 2 times 5 is 5 root 2. So y equal to 5 root 2. That is, the length of this side is 5 root 2 kilometers. Now let's look at triangle ABR. It is also a right angle triangle, and we have the length of this side to be 10 kilometers, while this is 5 kilometers. We can also use the Pythagorean theorem. This side BR is the hypotenuse. Let's assume its length to be z. By Pythagoras, the square of this side must be equal to the sum of the squares of this 10 kilometers and this 5 kilometers. So z squared equal to 10 squared plus 10 squared is the same as 2 times 5 all squared. 2 times 5 all squared is 2 squared times 5 squared. 2 squared is 4. Now from 4 times 5 squared plus 5 squared, if we factor out 5 squared, it will be 5 squared open bracket 4 plus 1. 4 plus 1 is 5. So z squared equal to 5 squared open bracket 5. Take the square root of both sides. Here square root of z squared is z, while here square root of 5 squared open bracket 5 is 5 root 5. So z equal to 5 root 5. That is, the length of this side BR is 5 root 5. But we'll just write it out here. Line BR equal to 5 root 5. Now still from triangle BR, we can use the SOHCAHTOA. Taking this angle as theta, let's say this is A. So theta equal to 45 degrees plus A. Though we'll also let 45 degrees plus A equal to B. So theta equal to 45 degrees plus A, which equal to B. Now from this angle, this is the opposite and there is the adjacent. Here tan theta equal to opposite over adjacent. Theta is B, opposite is 10 and adjacent is 5. So tan B equal to 10 over 5. 10 over 5 is 2. Now we have tan B equal to 2. Keep it aside. From this triangle here also, if we take this angle as theta, this is the opposite and this is the adjacent. We know tan theta equal to opposite over adjacent. Theta is 45 degrees, opposite is 5 and adjacent is also 5. 5 over 5 is 1. So tan 45 degrees equal to 1. Now come back to this 45 degrees plus A equal to B. Take 45 degrees to the right. So A equal to B minus 45 degrees. We take the tan ratio of both sides. So tan A equal to tan B minus 45 degrees. Now from trigonometry, there is an identity that tan x minus y equal to tan x minus tan y over 1 plus tan x tan y. Let x equal to b and y equal to 45 degrees. So tan b minus 45 degrees equal to tan b minus tan 45 degrees all over 1 plus tan b tan 45 degrees. From here, tan b equal to 2 and here tan 45 degrees equal to 1. Substitute these values here. So tan b minus 45 degrees equal to 2 minus 1 over 1 plus 2 times 1. 2 minus 1 is 1. 2 times 1 is 2. 1 plus 2 is 3. So tan b minus 45 degrees equal to 1 over 3. Come here. Replace this tan b minus 45 degrees with 1 over 3. So tan a equal to 1 over 3. Now suppose we have a right angle triangle which has one of its angles to be the same size as this A. From this A, we know this is the opposite and this is the adjacent. Comparing this equation to tan theta equal to opposite over adjacent, theta is A, this opposite will be equal to this one, and this adjacent will be equal to this 3. That is, this side is 1 unit and this is 3. This we can see is the hypotenuse, let's say V. So using the Pythagorean theorem, the square of this V must be equal to the sum of the squares of this one and this 3. So V squared equal to 1 squared plus 3 squared. 1 squared is 1, 3 squared is 9, 1 plus 9 is 10. So V squared equal to 10. Take the square root of both sides. Here square root of V squared is V. So V equal to root 10. That is, the length of this side is root 10. Now still on this triangle, if we use the SOHCAHTOA, taking this angle as theta, this is the opposite and there is the sin theta equal to opposite of our hypotenuse. Theta is A, opposite is 1 and hypotenuse is root 10. So sine A equal to 1 over root 10. We're done with this triangle. Now let's look at this line AB here. It is a tangent to the circle at this point. And this side BR is a second line. They both meet at this point, which is an external point. There is a rule that if a tangent meets a secant at an external point, the product of the secant and its external segment must be equal to the square of the length of the tangent segment. This side BP is a tangent segment, which is 5 kilometers. This line BQ is the external segment of the secant. Let's call its length S. The whole length of secant BR we have here to be 5 root 5 kilometers. So by this theorem here, 5 squared equal to 5 root 5 times S. 5 root 5 times S is 5 root 5 S. 5 squared is 25. So 25 equal to 5 root 5 S. Multiply both sides by root 5. Here 25 times root 5 is 25 root 5. While here this root 5 times this root 5 is 5. And 5 times 5 is 25. So 25 root 5 equal to 25S. This 25 cancels this 25. Therefore, S equal to root 5 kilometers. That is, the length of this side is root 5 kilometers. But recall, the whole length of line BR is 5 root 5 kilometers. So since this segment BQ is root 5 kilometers, this line QR must be 5 root 5 kilometers minus root 5 kilometers, which is 4 root 5 kilometers. Now one of the formulas for calculating the area of a triangle is half the product of the length of two of its sides multiplied by the sine ratio of the angle between them. That is, the area of this triangle PQR can be calculated by half the product of the length of this side PR, which is 5 root 5 kilometers, and this side QR, which is 4 root 5 kilometers, multiplied by the sine ratio of this angle A. So area of triangle PQR equal to 1 over 2 times 5 root 5 times 4 root 5 times sine A. 1 over 2 times this 4 is 2. 5 root 2 times 2 root 5 is 10 root 2 times 5. 2 times 5 is 10. So area of triangle PQR equal to 10 root 10 times sine A. The value of sine A we have here to be 1 over root 10. Substitute here. Now 10 root 10 times 1 over root 10. This root 10 will cancel this root 10. Therefore it is 10. So area of triangle PQR equal to 10 kilometers squared, which is the yellow triangle which you are asked to calculate its area. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.